Today we're going to start talking about a true necessity in chemistry called formula writing and formula naming. Okay, so this is really important. It is the language of chemistry. It is crucial that you practice and understand how to write a formula, how to name a formula. There are two different types of formulas that we're going to deal with. And the first type we're going to do is what's called ionic. And then there'll be a second video called covalent or molecular formulas. Okay, so we're going to start by doing things that deal with positive and negative charges, that wonderful Coulombic force of the attraction and the distance over which that attraction occurs. So when we do this, and again, there's two different types. We have ionic, which is based on charges, and all ionic things are salts. And then we have, as another type, molecular, which we'll talk about later. Okay, now, actually, I think I will do some highlighting here. Again, when you write a formula when it's ionic, you are basing it on charge. A charge is this thing called an oxidation number. Oxidation means the charge of an ion. Okay, so when we say charge, we're talking about the charge on an ion. Remember, we just learned how to make an ion, that you can have positive ions and you can have negative ions. Something loses an electron, something gains an electron. Okay, we're going to focus on positive for a second. A positive ion is called a cation. So fill these in, fill in your little ovals. If you print it and you don't put a tail on the T, and you look at the cation, the T looks like a positive. So that's one way to remember cation is a positive. Please understand, this is not a cation, it is a cation. So if you think of a little kitty with a little positive nose and its little whiskers coming out, right? So like if you draw a little cat figure, right? I have a little kitty who has a nose, right? And then the mouth that comes down. The nose usually is this little positive there. And you can say, okay, now I have my whiskers coming off the nose. Legs over there on the right. And you gotta give its little ears. And I guess you could put in eyes, nose, mouth, all that stuff. But it is the positive, and it is a cation. Right? When we talk about cations, there's two different types of cations you can have. The majority of them come from metals. Okay, the majority of them come from metals. Metals losing an electron to become positive. Calcium 2+, sodium 1+, aluminum 3+. Those metals give up their electrons, and the electrons transfer over to the anion. The anion is the negative ion. I'm going to have to change my highlighter over there because I used a purple pen when filling in my notes. So I'm going to change it to green. Right, so these are usually nonmetals. We have a transfer. Again, transfer of electrons. Right, transfer of electrons. Okay, they go from the metal to the non-metal. Metal loses, non-metal gains. The negative ion is called an anion. And in the AN, there is an N. The N stands for negative. This is not an anion, like an onion. It is an ion. And again, cation. There are some generic rules that you can follow based on position of your periodic table. And those rules are off and around that little anion thing. If you are a group 1 metal, it will be a positive 1 charge. Anything in group 1, if it loses its electron, it'll end up a positive 1 charge. A group 2 will be a positive 2. A group 13, which is under aluminum, will be a plus 3. Ooh, that 3 didn't come out very well, so let me see if I can rewrite that in. There's a 3 there. Okay, plus 3. Now, if you are on the opposite side of the table, like fluorine, anything, and fluorine will always be a -1, always. Fluorine's never positive. Okay, oxygen's a -2, and that group is predominantly a -2. Oxygen has a weird thing where it could be this thing called a peroxide. A peroxide is a polyatomic ion. Those are the things you have to memorize. All right, we are going to focus on the left side of this, called binary compounds. When we talk about binary, we're talking about the prefix bi, which means 2. So there are 2 symbols in the compound. 2 different types of elements in the compound. Not the total number of atoms, the different types of elements. So if I got a variety of compounds written there. We have sodium chloride. So you have 1 sodium, 1 chlorine. You have calcium chloride. 1 calcium, 1 chlorine. You have aluminum oxide. 2 aluminums, 3 oxygen. All of those are binary. Okay, they all end in IDE if it's a binary. So that's a key when you go to look at a name of a compound, with a couple of exceptions, because remember there's always an exception to the exception. If it ends in IDE, the name, you have a binary compound, 2 different chemical symbols. Only 2 different chemical symbols. That's binary. Okay, so as we look at our notes here, one of it says, let's look at aluminum sulfide, the name aluminum sulfide. The first thing you do is you look at the 2 things that are coming together. Aluminum, pretty straightforward. That's something you had memorized for your element quiz. You write the symbol down, Al. See, now you know the method to my madness. If you memorize those elements, you're not sitting there having to ponder what is aluminum. It should come to your mind, oh, that's Al. Okay, now we look at the second word, sulfide. So I look at the root, which is sulf. Sulf means sulfur. Sulfur is S. So I write the S. Then I go and look at the position on the periodic table to help determine the oxidation number. Oxidation number has to do with position on the periodic table. Aluminum is group 13, so aluminum will be a +3 charge. Sulfur is below oxygen, so that group will follow a -2 charge. When I write those charges next to the symbol, I ask this question. Do those charges add up to 0? And if the answer is yes, you just rewrite them close together. In this case, the answer is no. So you might say, well, what do we do? I have to move the paper. Okay, because they do not add up to 0, we do this very simple thing called crisscross. We take this charge, absolute value, and cross down the number to here. We take the absolute value and cross this down to there. And we come up with Al2S3. What the crisscross effectively does is it makes sure that all the positives in the compound, total amount of positives, will equal the total amount of negatives, because a compound is neutral, Right? There's a big idea here. A compound, any compound, is neutral. There is no charge next to a compound. It is neutral. Okay, I'm going to say it again. A compound is neutral. So when we look at these two charges, sets of charges, I have two positive 3s. That's my aluminum. I have 3 negative 2s. This is the sulfur. I have a positive 6 and a negative 6. When I add all those charges up together, I equal 0. Okay, this is the foundation of why you write the formulas the way you do. A compound must be neutral. All the charges from the ions in the compound have to add up to 0. If you have a metal, with the exception of a polyatomic ion called dimercury, because we never use prefixes in metals except when you have a polyatomic ion, or mercury 1 is the other way to name it. Your subscripts you come together with should be in the simplest ratio. So, again, I always try to teach you, ask the question once you put the symbol and the charges, do the charges add up to 0? Because if you ask that question here, on this one called calcium oxide right there, those two charges, +2 and -2, add up to 0. And since they add up to 0, you just write it neatly next to each other, because the proper formula for this is CaO. Simplest ratio. You simplify if you have a multiple when you have a metal in the formula. Okay, again, I will always tell you there are always exceptions to the rule. But right now at this level, you simplify when you have multiple subscripts of each other. You can divide through by the same number if you have a metal. Down below is sodium sulfide. Sodium sulfide is an example where you'd go and say, okay, sodium Na is my symbol. It's group 1, so it's +1. Now, a lot of times, guys, the convention is just to write the plus sign. You don't need the 1, it's understood. Sulfur, we said, was 2-. Again, absolute value of the charge, crisscross. You don't take the negative or the positive with you. You're crisscrossing the magnitude, how much you have. All right? I asked that question. See this right here? It does not add up to 0, so I crisscross. Always ask that question. And then you don't have to write any 1s. It's assumed. Notice how the sulfur doesn't have a 1 here. We don't need to write that. It's assumed that the 1 is there. Okay? So, a little bit below on the bottom of this note, and I'll have to, just to get to that bottom page of the note here. If you notice the very bottom, it says a metal with a nonmetal. You will always have the simplest ratio. That's called an empirical formula. We'll learn more later on empirical formulas. But terminology is key. If you can tuck away in your brain, empirical means simplest ratio. You will always have the simplest ratio for a metal with a nonmetal. The only time you have something funky with that is if you have a peroxide or a mercury 1 ion. Okay? Nonmetal with nonmetal, we will name by a prefix system. You can also use Roman numerals. And in there, you can have subscripts that are multiples of each other. This is not the simplified. Metal with nonmetal, always simplest ratio. Very, very important, very key. Now, I'm going to go off to a whiteboard right now and just go through some examples. So if you want to ever pull this up, you can look at it and say, okay, you know, she gave us some different examples. I'm going to take aluminum. What's a good one? Well, let's just start with aluminum fluoride. Right? here's my root, fluor. It's F. It's in group 17. We said F would have a -1 charge. Aluminum, group 13, 3 plus. Do they add to 0? So hopefully you would say no. So we crisscross. The 1 comes down to aluminum. I'm going to put it in there for now, but you don't have to write the 1. It's actually correct to leave the 1 out. And F3. We look at the charges. 1 times 3 positives plus 3 times 1 negative should equal 0. If we do the math, a +3 plus a -3, that adds up to 0. Okay? Calcium nitride. Ooh, nitride. We haven't talked about nitride. Nitrogen, we had originally said, has 5 electrons. Okay, it wants to go to 8 electrons. That's where it wants to get. So if I look at this, right, I start out with 5. You might say, why are you putting dots around it? Well, you're going to learn that. Now I have to put in 1, 2, 3. So I added 3 electrons. So nitrogen likes to have, my little red pen is really thick. Come on, red pen. Come down here. Not behaving today, that's okay. So nitrogen actually likes to have 3 extra negatives. So nitride will be 3 minus. Calcium is group 2. So calcium will be a 2 plus. Do they add up to 0? That does not equal 0. I will crisscross. Calcium 3, 2 nitrogens. But it's just called calcium nitride. Simplest ratio. Don't have to do anything to it. Magnesium sulfide. Okay, so this is magnesium's a 2 plus. Sulfur's a 2 minus. Ooh, they add to 0. Oh yeah, that equals 0. And I really should do this so you know it's not oxygen. It equals 0. I can write them neatly next to each other. I've done it. I've made the formula. But let's just say I get crisscross happy. It happens. I get in the mode crisscross, crisscross, crisscross. But this is 2 and this is 2. So we have to simplify. And if we simplify, it becomes MgS. Okay, I just want to find out what I'm up to. Sylvester's having brain farts. Okay. Other side of that page. The other side of the page has to do with polyatomic compounds. This comes from your polyatomic ion sheet. Memorize your sheet. Now, this is a little comment I made in class that because we are remote and we have people who stay fully remote and we have people who are remote on certain days, I give you open note, open book quizzes. Right? If this is a non-COVID year where you are all in class, you don't have that luxury. No matter what, AP says you're going to test in person right now. So you need to memorize that sheet. You need to know the names. Specifically, I'll go through and I'll condense it and I'll say, oh, absolutely know these. You really should know these others, and these are ones that we don't use very much. So we'll go through that. Okay, when you look at a formula and you see more than 2 symbols, you are polyatomic. Polyatomic is more than 2. So here's some example down below. Potassium's one of them. Nitrogen's a second. Oxygen's a third. I have 3 symbols. Now, over here, they're split up, and you might say, well, why is that? We'll learn. We'll learn that. Okay, so hold on if you've got that question. I have nitrogen, I have hydrogen, nitrogen again, and I have oxygen. Okay, so that's 3. I have nitrogen, I have hydrogen, I have sulfur, I have oxygen. Ooh, we hit the big mother load there, that's 4. Okay, more than 2, they all fall under this thing called polyatomic. How do you recognize it from a name? The ending of the name is a giveaway. If it ends in ATE or ITE, ATE or ITE, that is a big red flag of I'm a polyatomic ion compound. Period. As accentuated by the beeping outside my house. I don't know if you guys can hear that. Okay, it comes from your polyatomic ion list. Now, aluminum we should know is Al. It may not be the first ion that's polyatomic. In fact, there's only one, the NH4 one, that we use a lot. That's called ammonium. All the rest are negatives. They're just negative dudes. Sulfate, if you look on your ion sheet and you find it, is SO4 2-. So just like the one before, we write the charges and we ask, do they add to 0? Right? This does not add up to 0. So guess what? We have to crisscross. Again, absolute value, bring it down. Absolute value, bring it over. But, here's the thing. This baby right here is an entity. It is a total thing. You need the S and the 4 O's to make the ion. It only exists as SO4. It doesn't exist as S alone or O alone. It's SO4. So we use parentheses to say, ooh, this stays together. Okay? This and this says this entity stays together, and I need 3 of that entity. They say taken 3 times. Sulfate taken 3 times because I need 3 of them. Okay? Crisscrossing. Still crisscrossing. I move my paper. So let's look at a couple examples, and then we'll go back to the whiteboard, and I'll try to pull off some of them without my ion sheet. I don't know if I can do it. Okay? I can, but you'll get to do it too. By the time we're done, if you're really practicing and you try to really learn them, it'll become second nature. It becomes another language because this is the language of chemistry. Just like you learn in math how to use numbers and symbols and equal signs and all that stuff, you speak math, which is the language of physics, which is really chemistry, and chemistry, biology is really chemistry, chemistry is physics, physics is math. So you learn another language. Okay, so let's look at a couple examples. We have calcium sulfate down there. Ends in ATE. ATE means that it's polyatomic ion. Right? We write the calcium, we write the sulfate, we write the charges. Oh, these do add up to 0, but if I didn't catch it, and I had 2 here and 2 here, I've got a metal. So if I have a metal, I have to simplify. Okay? Let's look at sodium sulfate. Oh, sulfate. Oh, by the way, sulfate, very common polyatomic ion. Very common. Used a lot. Okay? So we do the sodium, it's a +1. The sulfate is a 2-. I don't need parentheses here or here. I only need 1 sulfate, so I don't write the parentheses. Sodium doesn't need parentheses because it's a single symbol. It's not a group of symbols, so I don't need the parentheses. Okay, if you put parentheses around the sulfate, it's actually technically considered incorrect. So be careful with that. Okay, I'm going to do a couple quick examples, and then I'm going to break to eat my dinner. Okay, let's go to our whiteboard again. It'll come up with all the writing, and I'll erase it for you. So clear that out. Let's do a couple of examples. Oh, here's a common ion. Nitrate, NO3-1, as opposed to nitrite, which is NO2. minus 1. Notice the minuses didn't change, and what changed was you went from 3 to 2. Oh, let's look at sulfate. SO4 2 minus. Sulfite. SO3 2 minus. As I get a little carried away with my little S's over there. SO3 2 minus. Notice charged the same. Ooh, look at the difference. Things to watch out for. Oh, we can do that too. Chlorate. ClO4, only a minus 1. Chlorite. Ooh, can you predict what chlorite might be? Oh, I think I did that wrong. Yes, I did. I did that wrong. See, I'm getting old. I forgot my chlorate versus chlorite versus hypochlorite versus perchlorate. Okay, so chlorate should be ClO3 minus. Chlorite should be ClO2 minus. Notice the difference. This goes further though. Ooh, whoops, sorry about that. Come back here. Okay, if I do ClO4 minus, this is hyper, meaning 1 extra, chlorate, right? This is chlorate itself alone, and this is chlorite, and then if I go ClO minus, this is, and actually it's not hyper, it's perchlorate. This is hypochlorite. Notice the difference. 4, 3, 2, 1. Okay, so there's a pattern here, especially between the 8s and the ites. It's a difference of 1 oxygen. So we can make different compounds here. Aluminum nitrate. Al, 3 plus. NO3, just a minus. Doesn't add up to 0. Crisscross. I get Al. I only need 1 of them. But the NO3, I need 3 of them. Okay? Sodium nitrate's very common. Potassium nitrate's common. Silver nitrate's common. So, nitrate is a very, very common. This baby's very common. This one's very common. Phosphate's common. Things to be careful of. Exceptions to the ending in ITE. Not ITE. Yeah, ITE and ATE. Right, we have hydroxide. That's a polyatomic ion. Ooh, it ends in IDE. Ooh, careful, careful. It is OH minus. Written that way, not HO, OH minus. Okay, calcium hydroxide. You have to know in your brain hydroxide is OH minus. This has to set off little bells. Ding, 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 ding. It's an exception. It is not a binary. It would be calcium with OH. This is 2 plus. So now I have this taken twice. That's calcium hydroxide. Another exception is cyanide. That is Cn minus 1. Peroxide. Anytime it ends in a peroxide, it's 2 oxygens adding up to 2 minus. Not 1 oxygen, 2. So the oxidation number is less. It's an extra oxygen. There's that per. Extra oxygen per chlorate. 4. Extra oxygen per oxide. 2 instead of 1. Okay? Again, parentheses, non-parentheses. The only positive ion is ammonium. Ammonium is NH4 plus. That starts the formula. That's the other huge big, 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 big thing. Big thing. And this one I'm going to want it bold. So I'm going to make it thicker. Right? Positive ion. Always named first and written first. So you give the good news before the bad news. Positive before the negative. Positive ion always, named first and written first. If you have the name, it gets written first. If you have the formula, it gets named first. And naming is going backwards, picking it apart. Do I have two things so it'll end in IDE? Do I have more than two things? Is it an exception? Is it a normal ion? So we will continue that later. Okay, that's to get you started. We will talk about the other things that are on this page. Coming up, we're going to talk about elements with more than one oxidation state and covalent.